Now we want to look at source addressing modes. It's denoted as AS in the machine language nodes. The MSP 430 has 4 basic addressing modes for the source address. That means it's going to take 2 bits to encode that. 00 is the register, just using the register, that's the simplest. 01 is index, so that basically, remember, that's taking whatever's in index and it adds the register, whatever's in the register to it. Index is a variable that you set up at the top above your .text thing. This is like arrays, indexed register. That takes 2 cycles, by the way. 10 is register indirect, and that's 1 cycle. So that basically gets the memory address from the register, and that's what you use. And 11 is indirect with auto increment. It also takes only 1 cycle, so that's a very nice feature. When used in combination with registers 0 through 3, 3 additional addressing modes are available. That's because those are special registers. R0 is the program counter, and then you got the status register and so on. So you can do PC relative. In other words, you can jump relative to the PC. It takes the index plus the program counter. You can do absolute, so that means you can go to an exact address that you want to go to. Label is the address that you're going to. You can do immediate, so that means you could actually put a number in, actual number, like if you wanted to store 3 or put it, that's the actual number. And then with the constant generator, R2 and R3, you can go either -1, 0, 1, 2, 4, 8 from that, and that takes also 0 cycles. You can see the number of cycles on the other ones. So using the constant generator is 30% code savings, so it just makes it a little faster if you need those constants, 1, or -1, 0, 1, 2, 4, or 8. Now let's look at destination addressing, AD in the machine language. There are only 2 basic modes for destination address, so it only takes 1 bit to encode the destination addressing mode. 0 is just register, that's the simplest one. And 1 is index, read from the register. That's like takes index whatever plus whatever's numbers in the register, and that's where it's used. And that takes 2 cycles. When used in combination with register 0 and register 2, 2 more additional modes are available. That's you can go PC relative. You can go wherever you happen to be plus so many addresses, or you can do absolute addressing. That's ampersand label that goes to the actual whatever the number is and label. That's where it goes. You can store results in memory adds, store results in memory adds an additional clock cycles. Storing results in memory adds additional clock cycles. So let's look at instruction length and cycles, because that's important when you're trying to minimize the amount of time your code takes to execute, or you're trying to calculate how long it takes. So instruction length, remember there's format 1, format 2, and format 3. And notice all of them take 16 bits, and different parts of those 16 bits are used for different things in Format 1, Format 2, and Format 3, as we've looked at before. So that uses 1 word or 2 bytes for each instruction. 1 additional word, that's 2 bytes for each of the following addressing modes. So if you do like a move, and you do 10 R4, so that would be whatever address is in number is in R4, you add that to 10 to get the place where you're grabbing data, and you're moving that into R5. Really, that's you're really kind of doing 2 moves in that thing right there. It takes 2 more bytes to encode in machine language that assembly language instruction, like move 10 index addressing by R4 to R5. And also things like move count to R5, or count as a variable that you've defined, or move absolute P1 into R5. So that's the source index mode. So it requires 2 more bytes for each of those addressing modes. Also requires 2 more bytes for the source immediate addressing mode, like moving the number 100 into R5. Except when you use the the registers 2 and 3 for the constants. Destination index mode, AD equals 1. Also, when you do those things on the destination, an indexed or an absolute, or one that you've defined like count, that still adds 2 more bytes for each of the following. Okay, so instruction clock cycles. So how many clock cycles does it take to execute an instruction? That's what we're looking at here. And so generally it's 1 cycle per memory access. So let's look at that a little more closely. 1 cycle to fetch an instruction word. 1 cycle if the source is what do we call that? Indirect, or indirect with index, or immediate. 2 cycles if the source uses indexed mode, like for arrays. 1 to fetch the base address, and the second to fetch the source. It includes, and this also includes absolute and symbolic modes. Oops, man, what happened here? Okay. It takes, okay, so let's see. It takes 2 cycles if the destination uses index mode, and an additional 2 cycles, and an additional cycle if writing destination back to memory. Additionally, 1 cycle if writing to the program counter, that's R0, and jump instructions are always 2 cycles. So here's a quiz for you. What is the length in words and cycles for each of the following instructions? You might have to go back and look at all the rules we just talked about.